Okay, welcome to electrical machine lecture. In the previous lecture, we have discussed about the construction of DC machine. The DC machine construction is common for the DC generator and DC motor. So the construction is same. In simply, we can say that the DC motor can be operated as a DC generator and DC generator can be operated as a DC motor. So in the construction point of construction, we have discussed a different part of different part of the DC machine. It comprises of field winding, and the second is armature winding. Armature winding. The field winding is placed on stator, whereas armature winding is placed on rotor. So winding, when we call as a winding, it is made up of copper wire wound over the magnetic material. So definitely the copper wire having some resistance, and this resistance can be represented by the resistance of the field winding and resistance of the armature winding. So every time we are not going to draw the entire construction diagram, whereas we use some symbols. So the field winding, it is represented by large number of turns. It indicates the winding resistance is more, and it may represented as a field winding, and whereas the armature is represented because it is a rotating part, so it is represented as the armature which is rotating. For the DC motor or DC generator, it is generator, and this indicates that this is the DC generator, straight line. So this is the representation of armature. This is armature, and this is field winding. It is field winding. This is armature winding. Okay. So armature, when there is a winding is there, there will be some armature resistance. It is an ohm. Similarly, the field winding, it is represented as a RSH when it is connected in parallel with the armature winding. It is a RSH, shunt field resistance. And if the resistance is connected in series, so RSE is the resistance field winding which is connected into the series of the generator, series of the armature winding. So it means that the classification of DC generator based on the combination or the connection between the armature winding and field winding. So first we will write the DC machine, DC generator. DC generator. So one more thing which we have to explain, say as it is a generator, so it will deliver the current. So the current is known as the armature current, and the EMF induced in the generator, actual EMF induced in the generator is EG. Similarly, the current drawn by the field winding is ISH when it is connected in parallel. So it is a shunt current, and if it is connected in series, then it is called as a series, series field winding. So DC generator, it is classified into two major parts. One is the separately excited generator. Separately excited generator, and second is the self-excited generator. Okay. So separately excited generator and self-excited generator. Separately excited generator, it means that the excitation, why the excitation is needed? To produce the required amount of flux. Some current is needed to excite the armature field winding. That is to produce the required amount of flux with the help of electromagnet. So it is a separately excited. So the field winding, it is connected separately, independent of the armature. It is connected with the some resistance, variable resistance with the battery source, so that it is possible to control the current in the field winding. So this is the field current. It is field resistance, RSH, and this is the variable resistance, and this is the battery source, V, isn't it? And the armature, it is electrically isolated with the field winding, and it is going to generate the voltage. So this is the separately excited DC generator. The terminal voltage is VT. Current delivered by the generator is IG or IA, isn't it? And this is the two brushes are there on the, which is going to collect the current from the rotating part. As it is a generator, so this is DC generator. So EMF generated, it is EG, and terminal voltage is VT. So what is the difference between terminal voltage and EG? Because it is going to measured in the voltage, it is also going to measured in the voltage. The difference is that whenever it is connected with the load, it is connected with the some load, it's going to deliver the current. So some of the current, some of the voltage is going to drop across the armature winding, and rest of the voltage is going to appear across the terminal, across the load. So the voltage across load is the terminal voltage, and actual EMF induced is the EMF generated. Therefore, EMF generated is slightly greater than the terminal voltage, isn't it? So this is the separately excited generator. Whereas in the self-excited generator, there are again classification. First is the DC series generator. Series generator. Second is the DC shunt generator. And third is the DC compound generator. Compound generator. So it means that the DC series generator whose field winding and armature winding is connected in series. So we will draw the figure. This is the armature. And as the winding is connected in series, so it having less number of turns. And now it is connected with the load. This is electrical load. And electrical load is variable, depend upon the application. Okay. So the voltage across terminal, the voltage across load is terminal voltage VT. Current delivered by the generator is IA, armature current. It is a generator. So it is resistance is RA. Current delivered. Resistance of field winding is RSE. So here the EMF generated is EG. Okay. So this is for the DC. It is, say, we'll give the name A, this is B, and this is C. So this is A. What is A? A is the series generator. Okay. So now in case of series generator, what is the current in the load circuit? IL. So here we can say that load current and armature current is same because it is in series. Whereas the terminal voltage or EMF generated EG is equal to voltage drop across resistance, voltage drop across armature circuit, plus voltage drop is into the load terminal. So just we are applying the KVL and KCL. So EG is equal to terminal voltage plus IA RA plus IA RSE. So in short, EG is equal to VT plus IA into bracket RA plus RSE, where RA, what is RA? RA is the armature resistance. It is common for the, when we are going to study the DC machines. RSE, series field resistance. Series field resistance. This is the thing. And EG is nothing but EMF generated and VT is terminal voltage. Terminal voltage, isn't it? So this is the first thing. Second, it is the shunt generator. Shunt generator, the name itself, the armature winding and field windings are connected in parallel. So this is the field winding, armature, and here is the load. We are using switch. Again, the load is variable, depend upon the application. So this indicates a variable sign. Generator, DC, it can be represented as F1, F2. In the connection, it is A2, this is A1. It having resistance RA. This is having the resistance RSH. So shunt field resistance, it is going to deliver the total current IA. Current delivered to the load circuit is IL. Current delivered to the field winding is ISH, isn't it? Voltage across load is VT. This is the voltage across load. Whereas EMF generated in the armature winding is EG. So again, we will apply the KVL and KCL. So if you apply the KCL, we will get armature current IA is equal to IL plus ISH. No doubt, the ISH is very, very small than the load current because the load current is high. Say, for example, the load current is 100 ampere, whereas the shunt field current is hardly 2 ampere or 3 ampere is there, or it may be a 5 ampere. So comparatively, it is very large, very small. Now, if you apply the Kirchhoff voltage law, KVL, in this circuit, we will get EMF generated is equal to VT plus the resistance drop in the armature circuit, isn't it? And many times, if this is brushes are there, so because of this contact over the commutator segment, again there is some voltage drop across the brushes, so it is called as a brush drop. It is same, it will be valid for the series motor also, or you can write here it is plus the brush drop if it is given in the numerical. Sometimes it is not given, so we'll consider as a 0 value. So this is the equation for the DC shunt generator. For the DC shunt generator, the field winding is independent of the load, whereas in case of the series generator, as the load increases, the current in the field winding also get increases, and it will increase the more fluxes over the periphery of armature, isn't it? Whereas here the magnetic flux remain constant irrespective of the load current. If load increases, load current also increases, but there is no change over the say shunt field winding. Now, next category, it is the compound generator, isn't it? So next category is compound generator. In compound generator, there are two categories. One is the cumulative compound generator, and second is the differential compound generator. So what is the meaning? First, we will draw the diagram, and from the diagram, we will proceed toward the concept of compound generator, isn't it? So the diagram compound, it means that it comprises of shunt field resistance or shunt generator. This is the shunt field winding. Shunt field winding, and it is consist of series field winding also. So this part is similar to the DC shunt generator. And it is having series field winding also. And now it is connected to the load. So this is the terminal voltage, VT, series field resistance, RSE, generator, armature current, EMF generated, current delivered by the armature is IA, current delivered to the load circuit, and series field is IA is equal to IL, and this is the current delivered to the shunt field winding, it is RSH, and the current is this one. So simply, again, your armature current IA, if you apply the KCL at this junction, say KCL, IA is equal to IL plus ISH, because the diagram is same. Similarly, the EMF generated EG is equal to VT plus IA RA plus IL RSE. or it may be written as IAC. It is ISC, current in the series field winding. So you can write as it is equal to VT plus IA, because the current flowing through the armature resistance is IA, RA plus ISE into RS. So this is the shunt field compound generator. So in case of compound generator, there may be a two type. This is called as a short shunt because the armature is shunted by the field winding. There may be a long shunt. Long shunt means the shunt field winding encloses shunt armature as well as shunt field winding. This is the shunt field winding. It encloses the series field winding. This is series field winding and armature winding. So this is called as a long shunt because shunt field resistance is shunted the series combination of armature and series field winding RA, isn't it? This is the field winding F1, this is F2, it is A1, this is A2, this is S2, this is S1, and now the load is connected as it is. So this is called as a long shunt. It is called as a short shunt compound generator, and whereas it is a long shunt compound generator, isn't it? The rest of, say, if you write the equation, this is the armature current, this is the load current IL, this is ISH. So you can write the equation of IA is equal to IL plus ISH, very simple. Whereas for the EMF generated, EG is equal to VT. This is the terminal voltage, VT. Now apply the KVL over here. So VT is equal to the voltage drop in these two ones. So plus IA into bracket RA plus RSE, because the current flowing through the series field winding also the armature current. Now question arises, what do you mean by compound generator and differential generator, isn't it? So first we will consider the compound generator, cumulative compound. Cumulative compound generator. The meaning itself, there is a something which is cumulative, adding to each other. So if you consider the construction of field winding, this is the field winding structure, okay, and it is connected with the pole shoes. This is, say, pole shoes are there, and over which we will place the winding, isn't it? So if winding, there are two type of winding. One is the series winding and shunt field winding. So if the winding in such a way that, say, for example, this is the direction of winding, main winding, isn't it? So this is the direction of current in this way. So it means that this is the field winding F1, F2, isn't it? So if you hold the solenoid, if you hold this coil in such a way that by the right hand, in such a way that your finger shows the direction of current, finger shows the direction of current, then thumb shows the direction of North pole, or the fluxes, isn't it? Say this is the thumb and it is the finger which shows the direction of current in such a way that by the right hand, so this will be the north side and this will be the south side. So what is the direction of fluxes? The direction of fluxes is in this way. So this is the flux which is because of the main flux, main field winding. So this is say phi SH, isn't it? Now we will do the second winding in such a way that the current in the series field winding also be the same, but there are less number of turns. So this is also the same. Okay. So what is the flux? The flux which is created by series field winding, they are also in the same direction, phi SE. So what is the total flux? Total flux phi T is equal to phi SH plus phi A, and it is additive. It is additive in nature, and therefore the name become a cumulative compound generator. Whereas in case of differential generator, differential generator, what happened? Again, this is the structure of field winding. Field structure is there. This is pole shoes. Okay. And winding is carried out. Winding is carried out by the same way. This is say S1 and S2. Okay. Now the field winding as it is, as we have considered earlier. This is the direction of current. This is the direction of current. And if you hold this one, so the flux created by this current is in this direction. And this is called as a shunt field current. Shunt field flux F1, F2, it is phi SH, isn't it? But the series field winding is connected opposite. Opposite? Is opposite, and the current also in the opposite direction. So this will be the S2 and this will be the S1 in such a way that, so under such condition, the flux created by series field winding is down. So this is series field winding, and whereas this is opposite is the shunt field winding. So this is opposite is the shunt field winding. So what is the total flux? Phi T is equal to, this is T, okay, phi T is equal to phi SH, because it is in more large number of turns are there. So flux created by the shunt field winding is more, and the flux created by series field winding will be less. So minus phi SE. So here it is not additive, it is a subtractive. And because of subtractive, it is called as a differential generator, isn't it? So the construction and connection for the cumulative compound and differential compound looking same. Only what happened in case of cumulative compound generator, the current in the field winding, main field winding, and current in the series field winding is same direction. So it become a cumulative. Whereas if the current direction is opposite as compared to the shunt field winding current, then the generator become a differential generator, because the flux created by total flux created over the periphery of armature is not additive, it is a subtractive one. Therefore, it is called as a differential generator. So based on the connection, this S1 and S2 connection, The generator may be a cumulative compound generator and differential compound generator. So these are the some basic classification, and EMF equation and current equation from the simple diagram, that is a Kirchhoff voltage law or Kirchhoff current law, we can understand the classification of DC generator. So next time we'll see the EMF equation of DC generator. Thank you.